Welcome to another version of Ars Electronica home delivery and another session of Journey Through the Universe. Even though we are not traveling very far out into the universe today, because we will concentrate on the terrestrial planets, mostly Mercury, Venus, Earth a little bit, and Mars. And we'll end the whole session by traveling outwards, a little bit outwards out of our solar system to check out the exoplanets. But we are not leaving our Milky Way today. In the background you already see our favorite program Uniview in 2D, not like it's presented in 3D in here in the deep space to our visitors very often. But as long as you wouldn't see 3D on your computer, we switched stereo off. You can see the orbits of the inner planets. Here we have Mercury, here is Venus, this is Earth, and there is Mars at the moment. Then there would be the asteroid belt outside here, and the dwarf planet Ceres is orbiting in the asteroid belt. And farther out there are, of course, Jupiter, Saturn, Uranus, and Neptune. But that was another episode. We already did those gas giants and ice giants. So today we'll do the innermost planets. And I have this Android phone and can beam myself to the different planets, and we're starting with Mercury. We landed on the dark side of Mercury at the moment, so I'm going to turn it around. And what you see is something which looks very similar to our moon. It's a cratered landscape. Mercury can't keep an atmosphere because the solar wind is too strong in the vicinity of the Sun where Mercury orbits. When you look at Mercury in the night sky, you will always find it very, very close to the Sun, which means you can only see it at sunset or sunrise. And the strong solar wind there is also the reason why only two probes visited Mercury so far, and there are only images of 95% of its surface. But we don't expect a big surprise at the missing 5 points. There won't be a sea or something there. It will most likely look like just the rest of Mercury. Mercury is traveling high speed. It's orbiting with a velocity of 84 kilometers per second. And if we look at the orbit, it's very elliptical. We can zoom out and then we'll get the projection of the orbit of Mercury. So there is a theory that maybe Mercury once was a moon of Venus and is now a planet. It's a rather small planet. Two of the moons of the solar system, Ganymede, the moon of Jupiter, and Titan, a moon of Saturn, are bigger than Mercury. But Mercury is very, very heavy. It has twice the mass of Ganymede and Titan. It obviously has a core of iron and nickel, which makes it very heavy. They're still not sure why it is like it is. Maybe there was a collision in the early days of the solar system which kind of got rid of the outer layers, but it's not that they are not definitely sure what happened to Mercury. We can see this elliptical orbit here. And this is not stable. In 5,000 years it will run like that, and in 10,000 years it will be like that. So it kind of forms like a rosette around the sun, and this is the reason Mercury might not stay in the place where it is. There are theories which say Mercury would become unstable and either crash into the sun or kind of drift outwards in the solar system, which, there is a risk that Mercury might one day crash into one of the other planets, but this will happen in millions, if not billions of years, so none of us will be here to watch it. The next planet we are going to look at is Venus. Venus is the Earth's sister planet. It's only a tiny bit smaller than the Earth. It has a diameter of 12,100 kilometers. The Earth has 12,700. So they are very similar, but their atmosphere is not similar. Venus has a very, very dense atmosphere. This is the reason why in this optical image you cannot make out very much. But the atmosphere has a lot of carbon dioxide in it, and the pressure at the surface is 90 bars, the same as at the sea on Earth, at an ocean on Earth, in over 900 meters of depth. That's also the reason the Russians sent 16 Venera probes to Venus, and the first didn't even reach the surface because they had underestimated the pressure. And the ones that finally reached the surface didn't last very long, because they were smashed with the pressure and they melted with the heat, because on average the temperature on Venus is around 470 degrees. At this temperature even lead is liquid, tin as well. Venus, a day on Venus is longer than a year on Venus, because Venus orbits in retrograde motion. It's the only planet which is doing that. And maybe Venus had a collision as well, just like a protoplanet called Theia crashed into Earth and created Earth's moon. Maybe some protoplanet crashed into Venus and also created the retrograde motion of Venus. Means it takes Venus to do one full orbit 425 days, Earth days, and a day on Venus is over 460 Earth days long. Next we concentrate on our home planet, and again I'm going to zoom us close to Earth, and as long as I guess you know the geography of Earth, I'm not going to dig into that, but Earth has a very interesting magnetic field which you can make visible in this program. I can turn magneto on, and then there will be a visualization of Earth's magnetic field. Lately, the Earth's poles have been traveling rather fast, and they are moving, so the poles might change. The North Pole might become the South Pole, and the other way around. And this might happen rather soon, because it has been happening very often in the past. around every 350,000 years the poles are switching, and the last switch happened in 780,000 years ago. So we are kind of overdue. Why do we know that? Because every material which is heated above 1,000 degrees and then cooled off stores not only the strength of a magnetic field, but also the direction. And yeah, especially at the mid-ocean rift zone, you can gather sediments and can determine when the magnetic field switched. When this happened in the past, the Earth often didn't have only 2 poles, but up to 11 different magnetic poles. Very many conspiracy theorists might say, yeah, we will all die, which won't happen. Because what will happen in reality that the layers of the atmosphere of Earth will interact with the solar wind, and this will create the same strength of a magnetic field within 20 minutes as we have right now. The only problem with this is that there won't be a magnetic shield on the opposite side of the Earth, the side pointing away from the Sun. This is an effect which happens on Venus now. Earth has this magnetic field because it's kind of like a dynamo. It has a core, a liquid core, and because of the spinning of the Earth, this dynamo creates this magnetic field. Okay, next on our travel is Mars. And I did this talk on a Tuesday with Mars, and unfortunately, which happens rarely, Mars showed us the very boring side. You can see this side, it's red because of rust, but on the other side there are the Olympus Mons and Valles Marineris. It's still in the dark. I was hoping that we'll see a little bit of it, but the whole program is a real-time animation, which means the distribution of light and shadow at Mars is exactly as you see it in the background right now. And the Mars day is 24 hours, 37 minutes, and we are now streaming only 1 hour later than we did on Tuesday, so the situation didn't change very much. It only shows us the boring side. It's really hard to make out. Here would be Valles Marineris, but I'm pointing this out because I will do 2 talks next week. Here's Valles Marineris, and here is Olympus Mons, the highest mountain of the solar system. Next week on Tuesday we'll be doing the moons, and Mars has 2 moons, which means we will be visiting Mars. And then we can look if the light situation changed, and I might be able to show you these features. They are very interesting because Mars obviously has such a high volcano because it has no plate tectonics, and the Valles Marineris, which is called Marineris because it was discovered by the Marineris probe, is proof that Mars once had an ocean of liquid water. What we can see now are the pole caps, which are mostly frozen carbon dioxide, but there is also water ice in there, and there might be water ice below the surface. And what just happened is, can you see that if I turn it around again? Phobos just crashed through the picture. I It was going up here. Where is it now? If we can't find it, we can help ourselves, because we get the orbit displayed, and here you have the two Mars moons, Phobos and Deimos. Phobos is only 22 kilometers in diameter and Deimos only 12, but this will be a topic of next week's excursion. And as promised, now we are going farther out in the solar system, because those were the Earth-like planets, planets made of rock, and the other planets in the solar system are gas giants. But they already discovered they discovered exoplanets, and I can now mark stars which are orbited by exoplanets, and if we zoom farther out, we'll see them. Can you see the blue circles? All those obviously have exoplanets. We already know from over 4,000 the terrestrial exoplanets are difficult to discover, because they are very small, much smaller than the gas giants, but they found some. And one is here. This is Alpha Centauri. This is a star system consisting out of 3 stars, and the star closest to us is Proxima Centauri. Proxima Centauri has a planet, an exoplanet, which is kind of Earth-like. It is a terrestrial planet, and it might even be habitable, because it is in a zone where water could be liquid. But it is orbiting a dwarf star, and dwarf stars, they tend to have explosions and mass ejections, so it's very unlikely that life was created on Proxima Centauri. And with this and the announcement, then there will be the moons in German on Tuesday at 12, and the moons in English at 1 on Thursday, so exactly in a week's time. I say goodbye to you and hope you join us with other home deliveries. Thanks for your attention.